Okay, so first one is in this. First one is your halogenation of alkenes. By the halogenation reaction of alkenes, we can prepare a corresponding alkyl halide. Okay, now what? Suppose, for example, let's take a simple alkene. Okay, let's take a ethene, right? Okay, so this is your ethene. When you take X2, so the halogenation of alkene will give you a vicinal dihalide. So what will happen over here? This carbon-carbon double bond will break. Okay, we will break this carbon-carbon double bond. This will break, right? And new bond will form between this X. See this halogen. There are two halogen X2, right? So one halogen and one halogen. This bond will break. This will combine here to this carbon, and this halogen will combine to this carbon, and it will give you a corresponding. Basically, it will form dihalide. Okay, halogen over here and halogen again here, and here the hydrogen atom. So this type of arrangement of halogen atoms to the adjacent carbon. See, so see these are known as vicinal position, vicinal dihalide. This type of molecule is known as vicinal dihalide. Okay, now the question is, what is vicinal dihalide? Right. So when the halogen atom, two halogen atom is present on the adjacent carbon, okay, the neighboring carbon, okay, agal bagal. So this type of arrangement, this type of molecule or halide is known as vicinal dihalide. Vicinal dihalide, okay, means on the adjacent carbon. Okay, the halogen atoms are present on the adjacent carbon. And one more term is geminal dihalide. Geminal dihalide. So geminal dihalide is those type of halide. Just a second. Is that halide when the halogen is present on the same carbon atom. Carbon atom. Suppose this again this is your ethane, and suppose this X2, these two halogen group will attach on the same carbon like this. Okay, so these two X and X, these two halogen are attached on the same carbon. So this type of arrangement on this type of halide is known as geminal dihalide. Is it clear? Lubna
Yes, ma'am.
and yeah,
Yes, ma'am.
Putsia. Clear? So what is, just remember this term, vicinal and geminal dihalide. Vicinal means on the adjacent carbon. If the halogen atom is present on the adjacent carbon atom, then it is known as vicinal dihalide. And if it is present on the same carbon, so it is known as your geminal dihalide. Okay. Similar, it will be in the case of alcohol. Okay, if the OH group is present on the adjacent carbon, so it will be known as vicinal diols. Okay, and similarly, geminal diols when the OH group is present on the same carbon. Okay. So halogenation of alkene will give you a vicinal dihalide. Okay, vicinal dihalide. So this is your vicinal dihalide. Okay, write down this point. When alkenes are treated, alkenes are treated with halogen, with halogen. Okay, so they form vicinal dihalide. Vicinal dihalide. Clear?
Yes, ma'am.
Okay, one more point. Just write down in the notes part. Important note में लिखो. First point. Yeah. Bromination. Bromination is used as a test for unsaturation. Unsaturation. Okay, so we use this test, we use bromination as a test for the unsaturation. Okay, so suppose this CH2 double bond CH2. When you treat this ethene, okay, alkene, when you treat any alkene with a bromine, so this is known as bromination. So bromination of alkene, suppose you just treat it with Br2. Okay, so Br2 bromine is a brownish red. It's a brownish red color. Okay, what's the color of the bromine? So bromine's color is the brownish red color. Okay, so this is brownish red color, and when you add ethene, okay, when you add ethene in this bromine water, okay, bromine solution, if you take, so it will make this unsaturated, this double bond, this ethene, this CH2, CH2. Okay, this is a bromine similar to the halogenation reaction. So this one bromine will come over here, one bromine will come over here, the bond will break, and this bromine will attach to this carbon, and similarly this carbon. Okay, so when you do the bromination, again you will get a vicinal dibromide, right? Okay, so this is your colorless. This compound is colorless. Okay. So whenever you do the bromination of any alkene, okay. So because you know the color of the bromine is brownish red color, right? So when you put this brownish red color into the alkene, what happens that alkene changes into a colorless substance. That alkene changes into a colorless substance, and which shows the unsaturation test. Okay, which shows that there is a double bond. Okay, there is a double bond unsaturation between this alkene. Okay, so basically this bromination test is used as a test for the unsaturation. Okay, not for the saturation. If there is a double bond, okay, if there is a double bond or triple bond. Okay, so basically this test is for the alkene and alkyne. Okay, so this bromination is used as a test for the unsaturation. So ये क्या करता है, whenever you just add the bromine, okay, into this alkene or your alkyne solution, what happens due to this double bond? What happens? This brownish red color, it gets absorbed and it will give you a colorless molecule. Okay, so this colorless molecule when you get, so it will basically it confirms the test for unsaturation. It shows that there is an unsaturated compound, okay, जिसमें आपने bromine put की. Okay, so bromination is basically used as a test for unsaturation. Just remember this one. Is it clear, Lubna, Rimdha, and Utsia?
Yes, ma'am. Yes, ma'am.
Okay, write this point. After this, you can add one point over here that alkenes decolorizes. ये क्या करता है? It decolorizes bromine water. Bromine water, which shows the unsaturation. Okay, let's do some questions. Miscellaneous problem. So you have to write the products. Write the products for the following. For following. First question. When you do the bromination, PR2, what will be the product? Second, again you have to do the chlorination, halogenation reaction of this chlorine, alkene. Third one, cyclohexane, and here plus PR. Write down the products, everyone. Yes, Lubna, tell me the first answer. What will be the product in the first one? Lubna, are you there?
Yes, ma'am.
What will be the product in the first one?
Ma'am, we'll place BR on the second position.
Which this is a suppose this is a first position, this is second. So on which place? On
On
which
the second
carbon?
position.
On the second? Are you sure?
Yes, ma'am.
Rimda, Rimda, see. Okay. So you said that you will place the bromine over here. Yes, Rimda. Is she correct? Rimda and Hutsia. Tell me, is the product correct?
We should add bromine on first and second carbon.
Yes. Very good. Okay, very good. We will place the bromine because we are doing the halogenation reaction, bromination reaction, right? So we will place this is a double bond, right, over here. So we will place the bromine over here. And what I said, what I told you here, we will break this bond, double bond, and we will place this bromine on the first carbon and second carbon as well. Okay, दोनों ही कार्बन पे हमने अटैच कराना है the bromine. Okay, so here also you will place, you will attach bromine. This will be your product. Okay, Lubna?
Okay.
Yes. Okay, second one. Yes, Rimda, tell me the second one. What will be the product here? Suppose this is the first carbon and second carbon. Yes, Rimda, I'm asking you.
Yes, ma'am.
Second one.
Ma'am, it's supposed to be in first and second position?
Yes. Okay, so we will place the chlorine in the first as well as on the second position. So this will be your product. What's your third one?
We should add bromine to first and second position.
Yeah, so this will be your product. Bromine over here and here also. Bromine. Yes, Lobdas, the fourth one.
Yes, ma'am.
Tell me the product.
We should place bromine on the first and the second position.
Yes, very good. And what about the fifth one, Lubna?
Yes, ma'am.
What about the fifth one? What will be the product in this case? Anyone? Rimta, Kutsia? Just think about this UV. Okay, here I have added the UV radiation. Okay, so bromination in the presence of a light, UV light, will follow free radical halogenation, right? So it will follow free radical halogenation. And you know very well what's the order of free radical halogenation? First one being benzyl में सबसे fast होती है reaction. After that, the allylic carbon, then 3 degree, then 2 degree, then 1 degree. That was the order. Okay, we have discussed this in the previous class. See, we have discussed this already, right? So the rate of free radical halogenation depends on the stability of carbon free radical. Okay, and the rate is basically सबसे ज़्यादा किसमें होगा first benzylic carbon, okay, then allylic carbon, then 3 degree, then 2 degree, then 1 degree. Okay, so here if you observe this question, see the reactant. This is your reactant, right? This is your reactant. So tell me which type of arrangement you will see. Which type of molecule it is? Benzylic, allylic, 3 degree, which one? See, it's very easy. You can see this carbon, right? This carbon is sp3 hybridized, right? And this sp3 hybridized carbon followed by sp2. This is the sp2. So this type of arrangement किसमें आपने देखा था? Allylic one, right? This one was allylic one. So you have to attach this bromine. Basically, it will follow the free radical halogenation reaction, and carbon free radical will be formed over here on this carbon. So this carbon to which the sp2 hybridized carbon is attached, this carbon is known as allylic carbon. इस कार्बन को हम क्या कहते हैं? allylic carbon, right? So on this carbon the bromine will be attached. On this carbon you will double bond as it is and you will attach the bromine on this carbon. Why? Because this is the allylic carbon. Allylic carbon is more reactive than the rest of the carbon. Okay, first one is benzylic carbon, then allylic, okay, and so on. If suppose this is your benzylic, how you will see? This is your CH2 and Na group which is attached to this. So this carbon is known as benzylic carbon. Okay, so this carbon is known as benzylic carbon, right? So that's why I just attach the bromine on this carbon, not here, not on the double bond. Okay, and I think I just gave you this type of question in your homework also. Okay, this one, just a second. Yeah, these two questions was your homework, right? So similarly, this question also, this is your allylic carbon, right? So you will attach the chlorine here. This will be your product. Okay. Similarly, see the third one. Have you done the third one? It's again a free radical halogenation. Just tell me the third product. I
We
told
should
you
add
guys
one
to
second carbon.
which one is it? Suppose this is the first, second, third, and fourth. So
Third
which
carbon.
carbon? Yes. Why, Kutsia? Why, Kutsia?
Because it's 3 degree.
Yes, very, very good. Okay. So just that's why I told you to revise the notes. Okay. So in the previous class, as I told you, now what is the order? So order will be benzylic. After that, allylic one, then 3 degree, 2 degree, 1 degree. So see here, and this is the first carbon. So first carbon is 1 degree, right? Because only one group is attached over here. Second, see the second carbon is 2 degree. But the third carbon, this carbon is your 3 degree carbon. Okay, and you know very well the rate of reaction will be, okay, so here you will attach the, okay, chlorine. This will be your product. This will be your product. Got my point? Lubna, Rinda?
Yes, ma'am. Yes, ma'am.
Okay. So you have to just remember this order. Oh, and accordingly, you have to attach the bromine atom. Okay. Now the next topic is, let's suppose one more question. Let's discuss. Question is a hydrocarbon, a hydrocarbon C5H10 does not react, does not react with chlorine, with chlorine in dark, in dark, but it gives a, it gives a single mono, monochloro compound, monochloro compound, which is C5H9Cl. The molecular formula is given here in bright light, in bright sunlight, sunlight. So identify the hydrocarbon. Identify the hydrocarbon. This type of question can come in the exam. Okay, so the hydrocarbon, which is formula is C5H10. C5H10 किसका होगा? It is supposed to have alkene. Okay, but it's mentioned over here that C5H10 does not react with chlorine in dark. Okay, and alkene does not give the chlorination test in dark. Okay, alkene bright light में देता है, but dark में it won't react. Okay, with chlorine. So C5H10 will not supposed to be alkene. Okay, so आपका alkene नहीं होगा because you know very well what's the formula for alkene. So it's CnH2n. CnH2n. It's your alkene. So it's C5H10. आप सबसे पहले क्या बोलोगे? It should be alkene, but no, it should not be alkene. Why? Because alkene, here it's mentioned that C5H10 does not react with chlorine, okay, in your dark, but gives a single monochloro compound C9H9, C5H9Cl in the bright light. Okay, so alkene to hoga nahi. So what will be the formula? uh, how we can draw this structure, okay, and it should not be alkene, okay, double bond should not be there, okay, so see, the correct answer will be C5H10. If you draw the cyclic structure, C5, 1 2 3 4 5, 1 2 3 4 5, okay, C5, so it's again the structure is C5H10. Okay, its molecular formula is C5H10. Cyclopentane. So in cyclopentane, if it is a cyclic structure, when you do the chlorination, Cl2, when you treat it with Cl2 in the sunlight, in the sunlight, okay? So this, okay, So C5H10 does not react with chlorine in dark. Okay, so this is a double, single bonded. This is alkane. Alkane does not react with chlorine in the dark. Okay, so it would be in the presence of sunlight. It will give the reaction. Okay, and because all are sp3 hybridized carbon and all are basically a 2 degree, right? So कहीं पे भी आप attach कर सकते हो chlorine. You can attach this chlorine on any of the carbon. Okay, you will get the same molecule. This is your uh, hydrocarbon. Okay, chloropentane. This is your chloropentane. Got my point?
Yes, ma'am.
Yes, ma'am.
Okay, Rimda, is it clear, bache?
Yes, ma'am.
Any doubt in this?
No, ma'am.
Okay, write down the solution. And one more point you can write here that C5H10 is not alkene, is not alkene, as it does not react with Cl2 in dark. So first was the halogenation of alkene. Okay, A part. Second one, this was the halogenation of alkene. Now the second one, second preparative method from the alkene. It's again from the alkene. So write down the second one, hydrohalogenation of alkenes. Okay, just a second, I will be back in 1 minute. Okay. So hydrohalogenation of your alkene. Now, what is hydrohalogenation of alkene? So basically, in this reaction, we use your halogen acid. We use halogen acid and we just treat it with the alkene. Okay, for example, if we take again, we just take the ethene. Okay, when you add HX, Okay, what is HX? HX could be your X could be your either chlorine, bromine, iodine, anything. Okay, so halogen acid. So it will give you. So what you are supposed to do here, okay, listen it carefully. So this hydrogen, if it is a symmetrical alkene, if it is a symmetrical alkene, okay, just like a ethene, symmetrical agar hai, means both the carbon have same number of hydrogen. If both the carbon have same number of hydrogen, so what you are supposed to do, you can attach this hydrogen to any of the carbon, okay, any of the carbon, and to the other carbon you are supposed to attach this X. Okay, so H and X will come over here. So this hydrogen will make bond with this carbon, and this halogen will make bond with this, and this bond will be break. What you are supposed to do, just break the carbon-carbon double bond. Okay, pi bond you have to break, and the new bond will be formed here, which is CH bond and CX. Okay, so carbon-carbon double bond will be break. Okay, and the new bond will be formed between CH and CX. These new bond will be formed. Okay, ये करना है आपने. So this carbon carbon, okay, and here the hydrogen, okay, and here you will attach the X halogen. Okay, so this will be formed. This will be formed. For example, suppose we just take CH2 double bond CH2 plus HBr plus HBr. So see, just see, observe it carefully. This is a ethene, right? So this is the double bond, and the double bond to the double bond, the right side, the right group and the left group both are same. So this alkene is symmetrical type, symmetrical alkene. If you are treating the symmetrical alkene with the HBr, any halogen acid, what you are supposed to do, just hydrogen will attach, this pi bond will be break. Okay, so CH2, right? And here to the one carbon, you will attach hydrogen. Okay, so when I attach the hydrogen, you can attach it over here, and to the other carbon, you will attach bromine. Okay, so what will be the product? You can also write it as CH3. Two hydrogen was there, and you will attach the one hydrogen on this carbon, so it will be CH3. This is CH2 and Br. Okay, so on the hydrohalogenation of alkene, ethene, it will give you a bromoethene. Okay, it will give you a bromoethene. Got my point?
Yes, ma'am.
Rimda and Putsia?
Yes, ma'am.
Okay. Okay, let's do some questions. So it is all about the symmetrical type of alkene. Okay. If we take the unsymmetrical type of alkene, so there are some rules we have to follow. Okay. But let's do first the symmetrical type questions. Suppose this is your alkene plus your HCl. Now you have to write down the product. Next question. Suppose this is the first question, second one, third one, plus HB. Okay, now do this question. Suppose first carbon, second carbon, first carbon, second. Just write down the product. Okay, write down these three products. Yes, Lubna. First answer. What will be the first product?
Yes, ma'am. On the first position, we need to place H, and on the second position, Cl.
Okay. Okay, very good. So this will be your product. Yes, name the third one. This one.
Ma'am, in the first position will replace H
Okay.
and in the second Br.
Okay, good. Because it's a symmetrical type, so you can attach any this bromine group to any one of the carbon, either on the first or second. Okay.
Okay, ma'am.
Yeah. According to you, you just attach here. So it's again a correct one. Yes, Futsia, third one. This fourth one.
Yes, ma'am. First position H and second position bromine.
Yeah, good. Okay, now you can write down one point over here. Then we will discuss about the unsymmetrical type. When alkene symmetrical is symmetrical, then attach the halogen to any one of the doubly bonded carbon atom. Okay. And to the other carbon, we are supposed to attach the hydrogen and attach hydrogen on the other carbon. Okay, now the question is, what about the unsymmetrical type? What about the unsymmetrical type? So see, for the unsymmetrical type, there are some rules you have to follow. Suppose, let's take an example. We just take this one. Plus HCl. When you do the hydrohalogenation of this one CH3, CH2, CH3, right? So what will be the product in this case? Because as you can see over here, this is your CH3, right? This is your CH2, and this is double bond, and this is your this is your 1, 2, 3. So CH. This is your CH, and this is your CH. Now, what you are supposed to, as you can see here, this is a double bond. This is a double bond between this CH and CH. Now check if it is a symmetrical or unsymmetrical type. So this is the unsymmetrical type. Why this is unsymmetrical type? So this carbon has two hydrogen, right? This carbon has two hydrogen, but this carbon has only one hydrogen. Now the question is, because we are treating it with the halogenases, suppose here we are just taking HCl, hydrochloric acid. Okay. Now the question is, on which position, okay, to which carbon we will attach the chlorine and to which carbon we will attach the hydrogen. Okay, that's the major question. So here we follow a rule which is known as Markovnikov rule. Do you know what is Markovnikov rule? Anyone? Yes? No one? Okay, no problem. So see, so this is the hydrogen and this is the chlorine. Okay, so it will dissociate, this HCl will dissociate to form H plus and Cl minus, right? Cl minus. So this minus negative part, this chlorine has a negative charge over it because it's a more electronegative between the hydrogen and chlorine, right? So negative part will attach on that carbon. The negative part means chlorine will attach on that carbon which has lesser number of hydrogen. Okay. you have to attach the chlorine on that carbon which has less number of hydrogen. And you will attach the H positive part, okay, positive part of the halogen acid on that carbon which has more number of hydrogen, which has more number of hydrogen, right? So this role is known as Markovnikov's rule, okay, Markovnikov's addition rule, addition rule. Just remember this rule is very important. Okay, so again I'm repeating, if your alkene is unsymmetrical type, okay, if alkene is unsymmetrical type and you are doing the hydrohalogenation reaction, so you are supposed to attach the chlorine, the negative part, to that carbon which has lesser number of hydrogen, okay, and the positive part of the acid is H plus ion on that carbon which has a more number of hydrogen. Okay, so in this question, tell me on which carbon you will attach the chlorine and on which carbon you will attach the hydrogen. Yes, Rimdha. Rimdha?
Ma'am, from the whole equation?
Yeah, from the whole one. This, because we will talk about this carbon-carbon double bond, this double bond, right?
Yes.
Now tell me, on which carbon, you just tell me which carbon, like this carbon has two hydrogen and this carbon has one hydrogen. So on which carbon you will attach the chlorine, the negative part.
Ma'am, in the CH?
Yes, very good. Okay, on the CH because it has only one hydrogen. And according to Markovnikov addition rule, the negative part should be attached on that carbon which has less number of hydrogen, right? So what will be the product? CH3, right? And here CH and here you will attach the chlorine, right? And you will just open this, just break this bond, double bond, and here you will attach the H, okay? So it will be CH. CH3, CH, and on CH, you will attach the chlorine and CH, okay? To 2-chloro, it's propane. 2-chloro propane you will get on the hydrohalogenation reaction of this one. Got it?
Yes, ma'am.
Okay, Lubna, is it clear?
Yes, ma'am.
Okay, if you want to write down the proper Markovnikov addition rule, so just write it down. So that it will be easy for you to understand or remember Markovnikov's addition rule. Okay, so what does it do? It means that negative part of the reagent attaches to that carbon which has lesser number of hydrogen, which has lesser number of hydrogen, right? See, so in this type of unsymmetrical type of question, you will get two products. Okay, basically, the negative part will, according to the Markovnikov addition rule, the negative part will attach to that carbon which has lesser number of hydrogen. But in this case, two products will be formed, right? The major one will be the Markovnikov addition product. Major कौन सा होगा? The Markovnikov addition product. But other product will also be formed, means the chlorine will attach on the second position also, right? And that product will be the minor product. Okay, उसकी yield उतनी ज़्यादा नहीं होगी as compared to the Markovnikov addition product. Okay, so in your exam, if you are supposed to write down the major product, so just write down the only Markovnikov addition product. And if they just ask you the whole product, just write down the products. So you have to write down both the products, like major one as well as the minor one. Okay, so what you are supposed to do, this is your unsymmetrical alkene, okay, propane. Plus, when you do the halogenation reaction, what will be formed? So negative, this bromine will attach on which carbon? Suppose this is the first carbon, second carbon. So this carbon has two hydrogen, and this carbon has one hydrogen. According to Markovnikov addition rule, this bromine will attach on the second carbon, which has only one hydrogen. Okay, so you will get this product. Plus, second product will be also formed. Means bromine will attach on the first position also, but it will form in a minor. Okay, it will be a minor product. Wo product, that product was not according to the Markovnikov addition rule. Okay, so this product will also form, means bromine will attach on here also, but this product will be minor one. This is your minor product, but the major product will be your Markovnikov addition product, जिसमें आपने rule follow किया है Markovnikov. This is your major product. Okay, so two products will be formed in this case, but the major one, just remember, will be the Markovnikov addition product. Got my point?
Yes, ma'am.
Yes, ma'am.
Okay. Now the question is why this is your major product? Why this is a major product? Okay, so here, see. So I'm just showing it over here. This is your product. Wait, this is your first carbon. This is your second carbon. Now, when you take the HBr, okay, so you know very well this bromine is more electronegative, so it just pull all the electron. So what is electronegativity or electronegative atom? So electronegative atoms are those atoms which has a tendency to pull the electron towards itself. Okay, so वो क्या करता है? This bromine has a tendency, this is more electronegative, so it pull all the electron towards itself and it becomes negative. Okay, yeah, ये क्या होता है? It becomes partially negative and this hydrogen become partially positive. Now, this CH2, what will happen over here? Here, this bromine first attached to this carbon. Okay, this will form two. This is your H over here. The hydrogen will attach here. 1, 2, 3. Just a second. Okay. Yeah. What we are supposed to do, this is your second carbon, right? Suppose this is the first carbon, second carbon. So second carbon has only one hydrogen. Okay, so it will first, we will follow the Markovnikov addition rule. So this bromine will attach here on the second position. But before attaching the bromine, here on this position, on the second position, the carbocation will be formed. Carbocation will be formed, positive charge over here, and hydrogen will attach on this position. Sorry, plus Br minus. Plus Br minus. Okay, so what happens over here? Because this bromine is more electronegative, right? So it just pull all the electron towards itself. It attains partially negative charge, and this hydrogen will attain a partial positive charge. Now, this carbon, this bond is partially, basically double bond is more electronegative as compared to the single bond, right? What will happen? This one, this attract this hydrogen. तो यहाँ पे इस कार्बन पे ये हाइड्रोजन will come and attach over here, and on this carbon there will be a formation of carbocation. Okay, so basically this which type of carbocation it is? So this is a secondary carbocation, right? This is your secondary carbocation. And when, suppose, when the hydrogen attaches on this second position, so what will happen here? The hydrogen will attach on the second position, and here the formation of carbocation. This carbocation is your primary carbocation. Okay, plus Br minus. Okay, so this is your primary carbocation. This is the secondary carbocation. And just remember, the primary carbocation is less stable. This is less stable as compared to the secondary. The secondary carbocation is more stable. This is more stable. Due to the more stability, the bromine will come and attach over here, and it will follow the Markovnikov addition rule. Due to that, this stability condition, this product will be the major product. ये major product होता है your this Marconic of addition product will be the major one. Why? Because it forms the secondary carbocation. Okay, and in this case, it forms the primary carbocation. Secondary carbocation is more stable as compared to the primary one. सबसे ज़्यादा stable कौन सा होता है? Tertiary one. Tertiary, then secondary, then primary. Okay, due to that, the major product will be your Marconic of addition product. This one. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, this was the Marconic of addition rule. The opposite of this is anti-Marconic of addition. Just very opposite. If you remember this one rule, so other rule already you will do that because it's just opposite. Okay, both are equally opposite to each other. Suppose this in the Marconic of addition rule, what we have learned, the negative part of the reagent will attach to that carbon which has less number of hydrogen. But in the anti-Marconic of addition rule, what happens? The negative part of the reagent will attach to that carbon which has more number of hydrogen. That's the difference. Okay, बिल्कुल opposite करना आपने. So okay, so just remember only one rule. So both rule will be clear. See, write down the heading. What is anti-Marconic of? Anti-Marconic of addition rule. But there's a slightly difference between the Marconic of anti-Marconic of addition. So this rule is also known as peroxide effect. Peroxide effect. Peroxide effect. Why it is known as peroxide effect? Because in this rule, the reagent के साथ साथ like Br2 के साथ साथ we just need hydrogen peroxide also. Okay, if the hydrogen peroxide is present, okay, in the hydrohalogenation reaction, then you will follow this anti-Marconic of. Okay, I just told you one more thing over here. If suppose we have an alkene, just a second. If we have a alkene, so if it is symmetrical type, so it's very easy. Okay, it is very easy, just like your carbon-carbon double bond. If it is symmetrical, or if you are doing the hydrohalogenation reaction, so it's very for the symmetrical one, it's very easy for you to attach the hydrogen. You can attach the hydrogen on any of the carbon if it is symmetrical one. Okay, and you will get this product. This, okay, and here the bromine. You can attach this bromine on this carbon also and hydrogen on this carbon also. So in the symmetrical one, it is very sorted. It is very easy. You can attach the hydrogen and bromine to any of the carbon. But in the alkene, if the alkene is unsymmetrical or asymmetrical, so there are two rules. So if it is asymmetrical, so there are two rules. First rule, if the peroxide is absent, peroxide अगर absent है in the reaction, if on the arrow you won't see the peroxide, peroxide में लिखा हो सकता है और H2O2. H2O2 is hydrogen peroxide. Okay, so if peroxide is absent, so you will follow Marconic of addition. You will follow Marconic of addition rule if peroxide is absent. But if peroxide is present in the reaction, so what you have to follow? What you are supposed to follow anti-Marconic of addition rule. Anti-Marconic of addition rule. Is it clear?
Yes, ma'am.
Yeah. So just remember this trick. So it is also known as peroxide effect. Now, what do you mean by anti-Marconic of addition rule? So just write it down. It occurs in the presence of peroxide or helper. Yeah, peroxide or helper, H-E-L-P-R. Okay, as I told you, the trick to remember, right? Helper, H-E-L-P-R, right? So in these reagent, if suppose peroxide is absent, so in these helper में से कोई भी आपका reagent use कर, like in the presence of a light, in the presence of any radical, electricity, okay, anything. So in the presence of peroxide or helper, when alkene is treated with HBr, with HBr, okay, HBr or any HCl भी हो सकता है, any halogen acid, then bromine, the negative part, means bromine is the negative part of the reagent, will attaches to that carbon which has more number of hydrogens, more number of hydrogens. Clear? So your negative part will attach on that carbon where the more number of hydrogen will be there. Suppose let's do some questions. First write it down. Written everyone?
Yes, ma'am.
Okay. Suppose this is the unsymmetrical alkene plus when you add HBr in the presence of peroxide. Suppose peroxide, we just take phenyl peroxide. Phenyl ring, oxygen, oxygen, and this. Basically, peroxide क्या होता है? There are this linkage, oxygen linkage, right? So this type of molecule, if it is mentioned in as a reagent, so you will use here. If you see the peroxide, अगर आपने peroxide देख लिया or any helper, okay, any HELPr, okay, like if you suppose in the presence of peroxide की जगह पे H nu लिखा हो or electricity लिखा हो or any radicals लिखे हो, anything with this reagent, so you will follow the anti-Markovnikov addition. Okay, means you are supposed to attach this negative part, means bromine atom, on that carbon which has more number of hydrogen. Now see, this carbon has two hydrogen, right? Two hydrogen, and this carbon has only one hydrogen. Okay. Now, according to the anti-Markovnikov addition rule, you will attach this bromine on which carbon? Where the hydrogen is more, means on this carbon. So you will attach here this carbon bromine. So that's the product. This is the major product. This is the major product. Okay, so when the peroxide is present, you will follow the anti-Markovnikov addition rule, and the anti-Markovnikov product will be the major product. But another product will be formed, and you will attach the bromine. In this condition, you will attach the bromine here on the second carbon. Okay? So this is your minor. This will be your minor. Is it clear?
Yes, ma'am.
Let's do some more questions. Suppose double bond CH plus HBr. Yeah. In this, here I have used H nu. H nu. Third one. Okay, please write on the product. And Lubna and what's here?
Yes, ma'am.
Okay,
Yes,
what's
ma'am.
your first question? Open with the answer. Suppose this is the first position, this is the second. So this is the first, second, first, second, first, second. Okay, now tell me.
We should add bromine to second carbon atom.
Okay, according to you, we should attach this bromine on the second. Because CH2, right? Just a second. Yeah. So you are following the anti-Marconic of addition rule, right? 1, 2, 3, 4 carbon with 1, 2, 3. Okay. Yes, Lubna, tell me, is she correct?
Yes, ma'am.
Okay. Second one. Yes, Lubna, yeah, this one. Tell me this answer. Where you will attach the chlorine, bromine
Ma'am, the second one.
on this. Okay,
Yes,
good.
ma'am.
Yeah, you will attach. Yeah. Okay, good. Yes. What's your next one?
We should add bromine to second carbon atom.
Very good. If I just remove this H nu from here, so we will use Marconic of addition rule, right? So in that condition, you are supposed to add the bromine on the first position. Okay, but remember here the H nu is there, so we will use anti-Marconic of CH3 over here, and on the second carbon you will place bromine. Yes, Subna, fifth one.
Second position.
Yeah, the second position. So 1, 2, 1, 2, 3, 4, 5 carbon and 1 2. So that's the product. Okay, so this concept is clear to everyone.
Yes, ma'am.
Yes, ma'am.
Okay, so the next reaction is halogen exchange method. So this was anti-organic. Okay, next one is your halogen exchange method. Okay, so in the halogen exchange method, as the name suggests that we are supposed to exchange the halogen atom. Okay, so in the halogen exchange method, there are three reactions. First one is Finkelstein reaction, then Swartz reaction, and the third one is your Hunziker reaction. And just remember, all the name reaction are very, very important for your exam. Direct question can come in your exam that what is Finkelstein reaction, what is Swartz reaction, right? So this reaction is again very important. So just uh, let's see. So first one, write down the first one, Finkelstein reaction. Finkelstein reaction. Suppose what happens in this reaction? So this RX, okay, alkyl halide, okay, alkyl halide, when you react it with sodium iodide, NaI, in the presence of dry acetone, in the presence of dry acetone, okay, and here the X could be your either chlorine, X क्या ले सकते हो आप either chlorine or bromine. You can't take the fluorine or sodium iodine because iodine is also here, right? And fluorine is most electronegative. So due to the most electronegativity, you will not take this bromine, fluorine over here. Sorry, fluorine over here, right? So Rx, okay? So when Rx could be your either chlorine or bromine. So Finkelstein reaction is when chloro or bromo haloalkene. Okay. When the chloroalkane or bromoalkane are treated with sodium iodide in the presence of dry acetone, so it will give you a iodoalkane. So what happens here? This X group, because it's a halogen exchange, okay? So in the reactant again a halogen group, and in the reagent, ये जो reagent आप use कर रहे हो sodium iodide, इसमें भी एक क्या है halogen group, which is iodine. So what happens here? The X group, which can be either fluorine or bromine group. So this halogen group is exchanged, replaced by this iodine. Okay, this iodine, and you will get Ri, iodoalkane over here. Sorry, iodoalkane, and what will be the byproduct? Na, sodium, NaX, and again X could be your either chlorine or bromine. Okay, if you are taking the chlorine RCl over here, so the byproduct will be NaCl. If you are taking the RBr over here, okay, so the byproduct will be NaBr, sodium bromide. So what you are supposed to do here, just exchange the halogen atom. Okay, so Finkelstein reaction is for the formation of iodoalkane. Okay, so Finkelstein reaction किसके लिए होता है? Is the formation of iodoalkane from the bromoalkane or the chloroalkane. Okay, and what are the reagent we use in this reaction? So sodium iodide in the presence of a dry acetone. Okay, now write it down. When chloro or your bromo alkanes are treated. They are treated with sodium iodide. Sodium iodide in the presence of dry acetone. It gives iodoalkanes. Got my point? Lubna and Pusia?
Yes, ma'am.
Yeah, so just remember the reactant which we use in this reaction, okay, and is the preparatory method for the iodoalkane. Okay, from the bromoalkane or chloroalkane. Okay, and reagent we use as a sodium iodide with dry acid. So that's a Finkelstein reaction. Suppose, for example, if in the reaction, if they just give you CH3, CH2, Br, and the reagent is sodium iodide in the presence of dry acetone. Okay, dry acetone. So this is a Finkelstein reaction. What you're supposed to do, this is a bromine group. Okay, so bromine group will be replaced by this iodine group and you will get CH3CH2I over here. Okay, iodo, iodoethane, two carbon chain, so it's a ethane, iodoethane plus what will be the byproduct? Byproduct will be sodium and this bromine, sodium bromide, NaBr. Got it?
Yes, ma'am.
Okay, now see, suppose I just give you the cyclopentane, chloro, cyclo, chlorocyclopentane plus the same reagent in the presence of dry acetone. Now tell me what will be the product in this case. Yes, Subna.
Iodopentane plus NaCl.
Iodocyclopentane is a cyclic structure, right? So
Yes, ma'am.
in the place of chlorine, we just attach iodine and byproduct will be sodium chloride. Okay, so that's a Finkelstein reaction. Finkelstein reaction. Now write on the second one, Swartz reaction. Second halogen exchange method is Swartz Swartz reaction. Yeah. Swartz reaction is for the formation of fluoroalkane. Okay, fluoroalkane or alkyl fluoride you can use. So what is Swartz reaction? So Swartz reaction is when you take your Rx and here Rx could be either similarly X could be your either chlorine or bromine. Plus when you treat it with your metal fluoride. What is M? MF? So it's a metal fluoride. Metal K fluorides. Fluorides. Okay. Then what will be the product? So here the product will be your alkyl fluoride. Okay. So Swartz reaction is a preparatory method of alkyl fluoride plus what you get as a byproduct, so metal plus MX. That's a general reaction. Okay, and what is MF over here? So metal fluoride. And metal fluoride you can take as your silver fluoride either or your mercuric fluoride, Hg2F. These two reagents are used as a metal fluorides. Okay, either silver fluoride or mercuric fluoride, Hg2F. Okay, so that's a general reaction for the Swartz reaction. Now write down this statement. When chloro or bromo alkanes are are treated with metal fluoride like your AgF silver fluoride or mercury fluoride, Hg2F2. So they gave fluoroalkenes. They gave fluoroalkenes. Okay, got my point?
Yes, ma'am.
Okay, let's do some questions. For example, write down the reaction. Example, suppose CH3Br. Okay, suppose we just take bromomethane, CH3Br plus your AgF, silver fluoride. What you are supposed to do, just replace this bromine group by this fluorine. Okay, so you will get CH3F. Okay, fluoromethane. Fluoromethane plus a byproduct will be your silver bromide, AgBr. AgBr you will get. Is it clear? Both the reaction, Schwartz reaction as well as Finkelstein reaction.
Yes,
ma'am.
ma'am.
Okay, please write it down. Okay, now write down in remarks part. Remarks. See, as you have seen here, the direct fluorination and direct iodination, we don't prefer. Okay, we don't do the direct fluorination and direct iodation, right? Iodination reaction. Was a reason because the fluorine is most electronegative and most reactive. Yeah, let's write it down. So why we don't do the fluorination? So direct fluorination means a direct reaction with F2. डायरेक्ट रिएक्शन हम F2 के साथ क्यों नहीं करते? Why it is not done? As F2 is highly reactive, and it gets violent. It gets violent, which cannot be controlled. Okay, ये violent हो जाता है. Due to that, we can't control the reaction. The reaction, if we use the direct fluorination reaction, so fluorine is very, very highly reactive due to its most electronegative nature. So the reaction will be very violent and we can't control that reaction. That's uncontrollable. Okay, so that's why we don't do the direct fluorination. Similarly, we don't do the direct iodination because this reaction is very slow. Okay, very less reactive and this is very slow. So due to that, हम iodination नहीं करते. Iodination. Direct iodination is not done for method of preparation of your haloalkane, haloalkenes. Why? As I2 is very unreactive or less reactive, you can write unreactive, so that the reaction is too slow. The reaction is too slow. That's why we don't do the iodination and fluorination reaction. Okay, we just prefer the chlorination and bromination reaction for the method of preparation of haloalkane. Okay, so one more reaction is left over here. So these are the two halogen exchange method. First one was Finkelstein reaction, okay, in which it's a preparative method of the iodo. Okay, iodoalkane. Okay, and what's the reagent? So sodium iodide with the dry acetone. In the Swartz reaction is a preparatory method of the fluoroalkane, and in this reaction we use metal fluoride as a reagent. Okay, third reaction is your Hunsdiker reaction, and the Hunsdiker reaction we will discuss in the next class. Hunsdiker reaction. Okay, so Hunsdiker reaction is basically a preparatory method of formation of bromoalkane. Okay, तो हम bromoalkane prepare करने के लिए we just use this reaction and it is known as Hunsdiker reaction. Okay, I think the time is up, so we will discuss this in the next class. Okay, Lubna and Kutsia, any doubt from today's session?
No, ma'am.
No, ma'am.
Okay, please बच्चों revise the notes as much as you can and just practice more questions. I just gave you, I think, 2 to 3 questions in the previous class as a homework. Did you submit that homework?
No, ma'am. We just got that homework just before the class. Just
Okay,
before
okay.
today's class.
Okay. I will check it right away. Yes, Kutsia, what about you? Have you submitted?
No, ma'am. I checked it
Okay,
today, but it wasn't assigned. Like today morning, I checked.
okay.